So welcome back, everybody. This is Bill Bittner from IBM. With us this afternoon, we have Richard Lewis of the IBM Washington System Center to tell us about ZVM Centralized Service Management. Richard does have a lot of material, so we're going to try to hold questions till the end, but feel free to put them into the chat while you think of them, and we'll catch up with them later. So with that, I'll turn it over to you, Richard.
Thank you, Bill. I sure appreciate it. As Bill said, what I'd like to do is cover the new ZVM Centralized Service Management that's going to be delivered with ZVM 7.2. So let's see here. Lost focus on my slides, so I'll go past the trademarks. What I'd like to cover is just very briefly the current service process. Most everybody, I'm sure, is familiar with that. A bit of an overview of what the objectives and components are for CSM, look at those in a bit more detail, and then spend time on a sample scenario. I think that's probably the easiest way to understand this new function and technology. So the current service process for standalone ZVM systems, I think everybody is aware that every system must be individually serviced. So if you have a bunch of VM LPARs and perhaps they're all clones of the same VM system, that doesn't matter. To service those systems, you have to go through the full process on each system. You've got to send the service envelope to each system, run through the full service process of receiving and applying and building that is encompassed in the service exec test, and then put that service into production. And so with a lot of LPARs, it becomes a fairly tedious process that can be error prone if you're not careful. And so the bottom line is customers have become very resourceful at developing their own service processes, and perhaps they're putting service on DASD and copying DASD and so forth. So many homegrown service methods. Now, for an SSI cluster, the story is a bit better. Since there are shared resources in an SSI cluster, it's possible to install service just once for all of the members in the cluster, and it doesn't matter which member actually you happen to install service on. All of the content that is written to the alternate service locations by the service exec is then available on any particular member where you might want to do testing. And then you put that service into production individually on each member in the cluster as it's possible to take those systems down. So the bottom line is you're really just adding service to the cluster once and then testing and putting it into production on each individual system. So with that in mind, the major objective of CSM is to eliminate the separate receive, apply, build of service on each non-SSI ZVM system, and therefore afford some of the efficiency that is enjoyed in an SSI environment. With 7.2 and the initial rollout of CSM, the CSM process is not going to affect how service is managed in SSI clusters. This process in 7.2 is exclusive of SSI. So if you're using SSI clusters, you don't have any non-SSI ZVM systems, then you won't be using CSM at this point. So what are some of the components and limits from a high level? CSM will introduce this notion of a principal system, and this is going to be a ZVM system that you're going to use to install and manage service levels for all of the non-SSI VM systems that will be known as managed systems. So within the CSM environment, you have those two classes of system. One principal system and then up to 54 managed systems are supported at this point with CSM. As I said just a moment ago, SSI is not involved, so the principal system can't be the member of an SSI cluster. The managed systems can't be members of an SSI cluster either. The service level, or the notion of a service level, is basically anything that you do from a service or local mod perspective to a system. So it could be an RSU. That's probably going to be the most common component of a service level, but a service level could be the RSU, the bucket. It could be local modifications, corrective service that comes from the service team that would be installed as local modifications. So that's what a service level is. And a service level is going to be built upon, to begin with, an installed base level of ZVM. So with CSM in 7.2, 7.2 is the base level. So this process will only apply to 7.2 systems, and there will only be one base level that CSM can manage, and that's 7.2. The service levels then that are produced on the principal system are going to be transported to managed systems using a special purpose FTP server on the managed system. And communication between the principal system and the managed system is going to be through that same special dedicated FTP server. So it's going to handle the content as well as the commands that are going to be implemented on the managed system. So a little bit more detail, we'll drill down just a little bit further here. In terms of user IDs and resources that are involved with CSM, some of these user IDs probably look familiar to you if you have a ZVM 7.1 system, because a number of these virtual machines have already been introduced into the default directory, even though nobody really knew what they were there for. So maint CSM is a new single configuration virtual machine, and it is the user ID that's going to be used on the principal system to do everything related to CSM. So that's where you're going to execute every command that's involved with either defining a managed system or defining a service level, and then packaging up that service level and sending it to a managed system. Another user ID, CSM work. It's defined in the directory, doesn't really have any resources associated with it, and it is the default only user ID that can be used with the dedicated CSM FTP server. So when you're communicating with a managed system, FTP is in use with that dedicated server, and the user ID and the password associated with that user ID would be CSM work. It's possible, if you don't want to use that virtual machine, to change that, but that's the default. You still have the regular maint VRM, or in the context of this 7.2 discussion, you'll still have a maint 720 virtual machine, and that virtual machine's role hasn't really changed. It's still the service and maintenance user ID for a particular VM system. It's possible to manage the service on the principal system through maint CSM. And so if you do that, then you would have to install a service level even on the principal system through the CSM process from maint CSM. But you don't have to do that. So in the case of a principal system that's not managed by by the CSM process, you'd still use maint 720 to install service the way you do today. Nothing would change. And the service structure, inventory, is completely separate from what's defined on main CSM. So there's no intermingling of service level structures on the principal system between what's maintained by main CSM and your normal service environment that you would execute from main 720. CSM serve is the virtual machine running the dedicated FTP server. And so again, by default, only CSM work is allowed to use that server from a login and password point of view. The VMPSFS file pool, so the file pool that would be a common system file pool in an SSI environment, but does exist on non-SSI systems. That file pool is the one that will be used to hold basically all of the information that's maintained by the CSM process. So on a brand new installed 7.2 system, you'll have just a regular VMPSFS file pool. It will be the default size. If you're going to implement CSM, you're going to definitely need to add additional file pool space to that SFS server because a lot more data is going to be stored in there. One file space ID that's going to be created related to the base level of VM that service levels are built on top of is this file space CSM-VRM. So again, to begin with, the only base file space in the SFS file pool will be CSM-720. So that represents the anchor for all of the service level structures that are associated with CSM. They'll all be directory structures underneath CSM 720. There will be a couple of new VMSAS data tables, the CSM system status table, and that will hold all of the critical information about a managed system, how to get to that system, what service level is current on that system, what service level might be pending, all of that kind of information. And then there's a service level table, CSM service stat, and that table is going to hold definition information for every service level that you maintain within CSM. Now, I mentioned that you're going to start with a base level of VM. So in 7.0, maint 7.0 will have a 5 Baker Charlie mini disk, and on that mini disk there will be a file pool unload file for the 7.2 base code. So this is truly the base. It doesn't actually include the RSU content that typically comes with a 7.2 install. It is purely the base. Now, as I said, the product doesn't ship with a huge VMPSFS. So in case you don't want to use CSM, you're not consuming a whole bunch of space you'll never use. So at the very beginning of implementation of CSM, you're going to have to add at least 355,800 4K blocks, and that's just to hold the base. You'll need additional space as you define service levels as well. So a service level is going to be a set of directories in the CSM 720 file space. So you'll have the base set of directories, and then every service level that gets built on those will be another high-level qualifier just underneath CSM 720. And that qualifier will be the name of the service level that you're actually building at that point in time. And the SFS structure that is created for a service level has all the directories, the delta apply build local mod, object sample, all the directories that would be associated with a component of VM, and that set of directories for every component and feature of VM. So um, the service level content then is installed into that set of directories. All of the inventory files that have been updated to manage that service level are also written into that set of directories. And in addition, a customized VMSESI profile and a CSM PPF particular for that service level are written onto the 5.1 dog for the directory representing the 5.1 dog for VMSES. When a service level is going to be sent to a managed system, and then the process to do that will create a bunch of component-based servlink files, and those will then be transported to the target system. Also within VMPSFS, and this is under the maint CSM file space, is the system level set of SFS directories. And so whenever you add a new system to be managed by CSM, a high-level qualifier will be added under the maint CSM root in the shared file system, and there will be directories there to represent critical information about the managed system, such as bitmap files for all the service that has been installed, and service log information, message information, and so forth. So all of that information will be kept in SFS as well. There, I mentioned on the previous slide that a CSM PPF is being used. So within the context of managing service levels, the traditional SERVP2P PPF file is not used. A CSM PPF is used, and overrides are created for every new service level, along with a corresponding VMSESI profile. When the service is actually put into production and used on a managed system, the regular service process is used on the managed system. So SERVP2P is the PPF that is being used under the control of CSM code on that target system. Now, one of the difficulties when you're building service levels revolves around various components that have many disks containing a nucleus, operating system nucleuses on them. So for example, the alternate CMS disk is the 490, and on the 490 disk you have nucleus cylinders for the CMS nucleus, and when you install service, a new CMS nucleus, if CMS is being serviced, gets built and gets written to those recomped cylinders on the 490. Since a service level is maintained entirely within SFS on the principal system and is transported in that context to the managed system, some updates needed to be made, particularly to the service exec on the side of the principal system, and a new tool called CSM package load on the managed system. And basically what's happening here is when a nucleus needs to be built on the principal system, the build nuke virtual machine is going to use a temporary mini disk to hold the nucleus, and then that nucleus is going to be written to that temporary target. The nucleus cylinders on that target are then going to be DDR'd to a file in the appropriate SFS directory for that build disk. So for example, it would be an SFS directory representing the CMS 490 mini disk. And then on the managed system, when the service level is being processed by CSM, the package load tool is going to take that file and DDR that file, DDR restore it to the appropriate nucleus cylinders on the target alternate service build mini disk. So that would be the target 490 on that managed system. So nuclei will be properly handled, even though everything in terms of building a service level is occurring in the shared file system. So everything about CSM is encapsulated in a new command called SERVMGR. So to do everything related with CSM on the principal system, you're just going to do a bunch of SERVMGR commands. Initialize is going to set up the shared file pool initial structures and actually populate that base. So do a file pool load of that unload of the 720 SFS directories, those base directories. There's a SERVMGR managed on and off function. I'll talk about that on, I think it's the next slide. That would be used on a managed system. So that's a command that you probably aren't going to use too often, but need to know about it. And then there's basically two subcomponents of SERVMGR. So there's SERVMGR system, where you do basically everything related to a managed system. You add it, you delete it, you modify its definition, you instruct the managed system to put service that's been sent to it into production, and then query commands to check service levels and so forth. There's another major subcommand of SERVMGR called SERVLEVEL, and that is the subcommand that has everything to do with service levels. So adding a new service level, deleting a service level, putting local mods onto a service level, running the service command to install service into a new service level, package up that service level, send it to a managed system. You can even do VMF setup so that you can get on main CSM the correct directory structure access, so you could look through that directory structure easily if you're trying to find various files or whatever in that service level. You can lock it from updates and then query it. So those are the SERVMGR is the command, and those are the subcommands that are related to SERVMGR. The main CSM names file can be used to provide nicknames. So if you have a bunch of systems that are being managed and you want to do an operation query, for example, all of those systems with one command, you can define a nickname within the main CSM names file. Let's say it's all sys or something like that. And then with the :list dot element, you can just type in or add all of the names of the systems that you want to include there, just space delimited names. And then you could use SERVMGR query, for example, for all sys as opposed to an individual system, and get a response back that has been sent to and received from all those target systems. There are updates to existing commands and execs. One update is to the main 720 profile exec. On the managed system, the CSM serve virtual machine is going to basically xautolog main 720 on that system and direct that virtual machine to run CSM code to process commands that are coming from the principal system. So there's a bunch of new logic that's been added to the profile exec to invoke this CSM agent code if the profile indicates that the virtual machine has logged on in disconnected mode. The bottom line here is if you used to make updates to the profile exec like I always did, you don't want to do that anymore because you don't want to risk introducing some sort of bug into that logic. So there is a commented portion within the profile exec that would allow you to add your code there, but there's also a commented out invocation of this exec called local exec or local config, excuse me, LCL CNFIG. And so if you uncomment that and you create a local config exec, you can put all of your code in there, which will be run when you log on to Mate 720. The service exec's been updated to support up to 16 character service names. So that's a change to the service exec. And then probably the most important change is there's now a new CSM managed tag in the system level service update facility table, the VM-sys-sof. And so that tag, when you add a system to CSM, so you're adding a managed system, part of the process of adding that system is to update the VM-sys-sof on that managed system and indicate that CSM managed is yes. And if it's yes, then it's not possible to use the service exec standalone on that system anymore. So if I decided, well, I want to log on to Mate 720 on that target system and run service to add some emergency piece of service, I won't be able to do that. And that's where that command that we looked at earlier, SERVMGR managed off and on, can be of use. So if you need to do something that's emergency service, you can't build a service level, you can log on to Mate 720, do a SERVMGR managed off. That'll flip this tag in VM-sys-sof, and now you can run service on the system. Now you have to be aware that when you then turn that managed tag back on, you're potentially going to have to go through some reconciliation process to sync up the principal systems view of the service and a service level that includes that with what was done on that managed system. Another probably more common use for turning off management would be if all of a sudden you decide, well, I purchased Performance Toolkit, for example, but I've never actually enabled it for use. And now Brian Wade's talked me into running all sorts of neat perfkit reports. So I want to enable perfkit on this system. I couldn't do that without turning off CSM managed. Because if I try to do service perf tk sfs, for example, enable, service is going to come back and say, nope, can't do that. This is a managed system. So that's not an emergency function, and it's not something that's going to change the view that the principal system has of the managed system. So you would just do a SERVMGR managed off, run your enable command, and then SERVMGR managed on, and you'd be fine with that. Okay, so let's take the last 15 minutes here or so to run through a sample scenario and hopefully try to fill in a few gaps with all these pieces and parts. So I'm going to start on the principal system. I've taken one of my VM systems and said it's going to be the principal. And I've decided I'm not going to manage its service with CSM, so I'm going to continue to install service on this system at business as usual. In fact, I might do that as a test case if I'm thinking of building a service level for a whole bunch of production VM systems that are managed by this principal. I might just install the service here first, re-IPL this system, and make sure that the service goes on well. There's no pitfalls that I might run into down the road. So the first thing I'm going to need to do on the principal system is add a bunch of space to the VMPSFS file pool. So um, I'm also going to want to make sure that I enroll main CSM as an admin. By default, it's not, but main CSM does need to be an administrator in the file pool. And so I'll add a bunch of space. Again, the absolute minimum is 355,800 blocks, because when I next execute the second command here, SERVMGR initialize 720, that's going to set up structures within the file pool for CSM, and it's also going to load do a file pool load of that unloaded file. And so it's going to install the base in the CSM 720 file space. It's going to create the service level table, and it will generate bitmaps and VVT local summary files for all those base components, and then update the service level table, and also create a service level description file in the base that has information about that that base release of VM. Now, once I've done that, I can actually add a new service level. And in fact, I'm going to want to add a new service level, because that base that I just installed doesn't include the RSU that came with 720. So I really need to have a service level right away that has that RSU included. So I would do that by using the SERVMGR serve level command with the add operand, and the version release modification level is 720. I've decided to name my service level VM010102 underscore build one. Don't ask me why, it's just a long name. And I have to indicate what this new service level is going to be based on. So it's going to be based on the base. And so base is the keyword that you would use. This service level is going to be for VM systems that don't have an external security manager. So I'm going to give it the non-ESM attribute, and then a description, which is just any freeform text. This is the initial RSU install. So CSM takes into account systems that have no external security manager, and systems that do, and service levels either have an ESM enabled or they don't. So if I have a mixture of systems, some have an ESM, some don't, then I'll need to create service levels. Even if they're identical in the service content, I'll need to create individual service levels for the ESM systems and the non-ESM systems. Now, once I've defined the new service level, and the service level add creates about 130 SFS directories under CSM 720.vm010102 underscore build one. So I've got a whole bunch of directories that include the base content. And so I want to add the service to those directories. So now I use the SERVMGR serve level service command, and this is basically just an invocation of service under the control of SERVMGR. So I include for serve level, I have to include the fact that this is a 720 level, and I have to include the name of the service level. And then after that, I include the operands I would typically include on the service command if I were installing an RSU. So I'm going to install all components from the envelope RSU 0801 serve link that presumably is sitting on the 500 mini disk that I've linked to main CSM. So service is just going to run as usual, and it's going to do its thing under the control of a individually tailored VMSESI profile that relates to this service level, and a CSM PPF that has been properly overridden to target all of the appropriate SFS directories that were created for this service level. When the service level is added to the CSM environment, and as I run the service command, the service level has a status of test. It's a test build state. And it will remain that way until I actually put it into production on a target managed system, and in which case it will become stable when that occurs. Now, once I've got a service level that would match a system that I want to manage with CSM, I can now add that system to CSM to be managed. So again, a quick recap on the principal system. When I wanted to set up CSM, I had to make sure that I made CSM an admin. I had to add space to the VMPFS file, VMP-SFS file pool. I also actually had to give main CSM class A. I forgot to mention that on the earlier slide. And that's because main CSM is going to be logging virtual machines, build nuke, and all of those for the service process. So on a managed system, I've got to do some setup as well before I can actually add that system to CSM. And again, I'm going to have to add space to the VMP-SFS file pool here, because we're going to be sending servlink files that are going to be installed into SFS directories that represent the service level. So I'm not going to need as much space as I had to add on the principal system, but I will need more than the default that is typically available in VMP SFS. To begin with, if you were to add a mod 9's worth of space, that would probably be sufficient for a while at least. I also need to make CSM serve and CSM work admins in the VMP SFS file pool. And I need to set up this CSM serve FTP server. So that's probably the biggest set of work that I have to do on the managed system. So that involves updating profile TCP IP. I'm going to add the ports for this new server. I'm going to add an auto log statement. I'll need to update or include an override for the foreign IP connection limit and the TCP pool size. Those are going to have to be increased as well. So, and I need to update the DTC parms file with a NIC for the CSM, a NIC statement for the CSM serve as an FTP class server, and include the CSM serve config file on the 198 as well. So once I've done all of that work and I have things prepared properly for the managed system, I can go back to the principal system and do a serve manager system add. And in this case, it's a 720 system. I give the system name. In my case, it's just VM01. I need to identify a service level that is either equivalent to the current level of the managed system or it is greater, so includes some service that isn't already installed on that target system. I indicate whether it's an ESM system or not, give a host name or IP address to be able to get to it. The communication type to that system is FTP. I don't really have to specify the port if I'm using the default ports of 4535 and 4536. I indicate whether it's a secure or not secure FTP communication. So CSM serve does support TLS like the standard FTP server does. So this will cause the principal system to communicate with CSM serve on the target system, It will gather a bunch of information about that system. It will bitmap the service level that's there right now, compare that with the service level I identified, and if everything pans out, then it will be added as a managed system on the principal. Now, once I've got that done, let's assume another RSU comes along. So I'm ready to use CSM to install this RSU on the target system. So I'm going to go through the same process of adding another service level. So it's again a serve manager serve level add command. 720 is the version we're using. And now I have a new service level name, VM010802 build 2, which is based on VM010102 build 1. So I've based my new service level on the previous service level, which was the RSU that came with the base system. I could keep building on every new service level. So if I get another RSU, I could add that RSU as a service level based on build 2 here in this context and just keep chaining these together. That's not really a good idea though, particularly since RSUs are cumulative. If I do that, then I can basically never delete a service level from the SFS file pool, which means I'm going to gobble up space at a very high rate. So probably a good rule of thumb for RSUs is to base them on the initial RSU and not base them on subsequent RSUs, so that as you install, create a new service level to install a new RSU, you could, once all the systems are off the old one, you could just delete that from the CSM service and free up all of the blocks in the file pool for that. So once I've defined the new service level, I need to run service to add that RSU content. So that's the same as what we saw earlier. I'm just going to install the content of that servlink RSU file. And then I'm going to package that service level using the serve level package command. That's going to create a bunch of servlink files. And if I don't want to inadvertently update that service level after I've sent it to a target system, I can actually set a lock on, which would prevent me from making any updates to that service level, but there's no requirement to do that. The service level is still in a test build state. Once I've packaged the service level, I can send it then to the target system. So serve manager, serve level send, 720, the name of the service level. The target system is VM01. All the particulars about how to get to VM01 are in the CSM system status table. So it figures out, what's the IP address and how do I use FTP to talk to that target system. The send process is going to actually physically send those servlink files along with a manifest and then invoke the package load process, which is going to take the content of those servlink files and install them on the target system in the alternate service locations that are owned by main 720. So it's basically the same as if you were to have run service without actually running service. So I'm just taking those serviced pieces and putting them in their correct location. And so if all that is successful, then I can go ahead and test that content if I want to, using the standard methods of testing service in the alternate locations on a system where I've installed an RSU or corrective service, for example. Now, the process also includes this notion of iteration. So while I was testing, maybe I decided, I missed a PTF that I really wanted to have on. It wasn't on the RSU, it wasn't in the bucket, but it's some new function that I really think I need. So I could go back on my principal system and I could run SERVMGR serve level service and install that PTF into that service level. I could package it, I could send it again. And presumably if I think I'm done, then what I want to do is send that service level with the stable attribute. So that way, CSM knows when I say I want to put this into production that that it's not a test level of service, but it really is a stable level that you intend to put into production. Now, there's nothing that would stop you. So if I forgot to send it as stable, excuse me, and I sent it as test when I really meant stable, I'll just get a question or a warning flagged when I'm running the put to prod command from the principal system saying, wait a minute, the service that you're trying to put into production is test. Do you really want to do this? And if you say yes, then it will automatically change the service level in the service level status table to be stable. So that again will prevent any additional updates to that service level. So once I have the stable service there, I use the SERVMGR system put to prod command 720 and the target system. And that essentially does a put to prod on that target system, just like you would be used to outside the context of CSM. And so once that is successful, I can re-IPL that VM system, and its status now within the principal system will be at this new service level, and all of that will be reflected in the inventory. So, wow, 2 minutes over. That's too bad. But we're at the summary here. So hopefully this has given you a bit better notion of what CSM is about and how it's going to roll out. So let's see. There's probably all sorts of questions here.
So there was quite a bit of chatter, but some of it was not necessarily directly to centralized service. I know Glenda answered some questions as well in the chat.
Oh, great. That's good. I'm glad Glenda was there. Okay, well then let me just ask if there's any additional questions.
So if you have questions, remember to unmute yourself or put them in the chat.
So is there a plan to add SSI?
Well, I can't reveal plans, but I can say that certainly extending CSM into the SSI environment is something under consideration.
Okay, oh, that's fair. So if there is a release of VM after 7.2, would it matter which release the principal system was and what the managed systems were? Or, you know, we're going to need to build a new 7.3 CSM environment?
No, you shouldn't need to. You could choose to if you want to, but you would be able to get the file pool unload from the 7.3 system and install that. But since the SSI file pool is probably going to get huge, and you're probably going to potentially want to draw down the number of 7.2 systems, you might want to maintain two principal systems. So a principal system for the 7.3 code and a principal system for the 7.2 code.
That's something if you're interested.
You only have one principal system, so it will keep you. That's why we have the keyword for 720 that you saw in his chart. And
Right.
when we go to 730, that keyword will be 730, so it'll go to the correct SFS directory for that service and verify that you were at the right level so you don't mix up your service levels?
Correct.
Okay. So,
But if you had an entirely separate 7.3 environment of principal and managed,
then I'd have to be shifting systems from one to the other, and
yeah, and you might not
uh,
want to do that. So the basic answer to your question is yes. That's why 720 is there, and every command you'll be
okay.
using 730. And since that is a file space within the SFS directory, I mean, there's no cross contamination. You're going to have a CSM 720 file space and a CSM 730 file space with service levels for that. The system level table doesn't really expand or change. I mean, a system that now ends up with a 7.3 level of service is just going to be reflected in the system status table.
Okay.
Right now, doesn't VMP SFS get recreated if you do a clean install? So when I installed 7.1, I got a new VMP SFS that was different from my 6.4. And when I install 7.2, am I not going to get another one? So how is that going to move forward? I guess I'm a little confused.
Well, if I do an upgrade in place, no, you don't get a new one.
That's true if it's an upgrade.
Right. And that's what you would want to do.
Okay.
Because if you reinstall, I mean, you do have to move everything over. A reinstall is a reinstall. It's a brand new system. But if you do an upgrade in place, you're going to simply upgrade that system.
Yeah, so upgrade in place is going to be a key component, and then we're going to have some kind of way to clean up because you're going to end up dragging stuff along that maybe you don't want to drag along too far.
Yeah, that's part of the cleanup, though, that's normal with upgrade in place, because, you know, with upgrade in place, once you've decided that the old release is, you know, can be safely deleted, you can get rid of, you know, all the old user IDs, and you can get rid of the SFS directories that would be related to an old release and so forth. Or if you're using mini disks, you can just get rid of the release volume.
Okay. And I think
within CSM as well. So remember, there were dependencies. So once you no longer use the 7.2 code within CSM, so, you know, the base and all the service levels that are related to it, once there's no system in the system inventory that's dependent on those, you can delete all that from the file pool as well.
And can you delete service levels too? I mean,
yes, as long as there isn't a dependency. So that's where I made the comment because I fell into that trap testing where I was putting cores and cores and cores, and I was just, every new set of cores was a service level that was based on the previous set of cores. And if you do that, then, you know, the highest level service level is still dependent on every intervening service level, even if some of those were, you know, included all of the previous service. So you just have to make sure how you use the based on attribute, that you do that in a rational way so that you don't create these long chains that you can't get rid of. As long as you don't do that, yeah, you can delete any service level that no system is using.
so based on doesn't copy everything to the new service level. It's more like a full backup and an incremental backup kind of thing where.
No, it copies. But for example, in the case of an RSU is cumulative. So, you know, if I create, you know, in my example, I had the GA RSU, if you will, as a service level. And my new RSU, I based on that because I sort of wanted to keep the GA one around. I figured probably forever. So that second RSU, that service level I created, that's a cumulative RSU, so it would have included everything anyway. I could have just based it off of the base and I would have been fine. In this example, I just kept that RSU level. But for any RSU, since they're always cumulative, I could always base them off the base and I'm fine. So when I do the serve manager serve level add, and I say based on base, what happens is all of the content of the base directories get copied over to this new service level. So basically now I have the base under a new name, and then I use serve level service to install the new RSU. So now I have that cumulative service in the service level, and I can then use that on a managed system. Now, when the next RSU comes out, if I base it off of the base, then once I've got that RSU installed on all my managed systems, I can easily erase that earlier service level because no system depends on it, and there's no dependency with any other service level that's been built, so I can now erase that. So serve level add always copies the directory structure from the based on element into the new service level. That's the starting point of directories. So if I've based it on a level that includes some other service level, then all of that content gets copied over as the starting point.
Okay.
Okay, so we're at the end of our time. So we can continue some of these questions in the chat,
Yep.
but I'm going to stop us now. Thank you very much, Richard. Obviously, this is an interesting topic. The only other thing I would add is that this is a new option. We're not saying that everybody has to use it, right?
Right.
So remember that, okay?
Yep.
All right, thank you, Richard.
You're welcome. Thanks.